Hey guys, welcome to a new video on scrap mechanics. Today we're going to be talking about, today we're going to be on a new world that I've just created. Kind of like a roleplay as well. I'm going to be doing some tutorials on it as well, specifically logic tutorials. So yeah, as you can see, I've got some building materials over here. This is just for like roleplay. I don't really need these, but it's just for like the beginning. I've got this truck here transporting some more metal over, whatever, to begin our base, because we're going to be building a base with all stuff in it and stuff. I think this is made by description by this person here. He also has a YouTube channel. You can look up this name as well if you want some more details on the Steam workshop. So as you can see, we've got pallets and stuff, whatever. So up here is going to be like the main entrance. Up here might have like some bits coming off like a cliff base or whatever. Got some cones, we've got some like skull and bones thing, so it's got some pallets over here randomly. Today we're going to be talking about like how a computer works, basically like how a computer actually does math and binary and stuff. So like the simple like broken down version of like a modern day computer, because obviously you can't build a modern day computer within scrap mechanic as it would be too laggy, and I don't think it's actually physically possible to, because of we don't have it's just too limited to do. But we can build a simple computer that can calculate a few things, but it's not very useful, but it's actually quite fun to like know how the computer works and stuff. So basically, a computer is composed of a few things. Obviously, you have like your RAM. Just pretend this is like the board that your computer sits on. So this is like your RAM. You might have a few like sticks of it coming out the board. And then this is your CPU, which is your central processing unit. You can get like Intel CPUs and like AMD CPUs in it. Different types of CPUs you can get and all different speeds in it. If you don't know what a CPU is and like what RAM is and whatever, you might want to look up some other videos on like computers and stuff. You might want to learn some more. Just pretend like the board under here is just a simple motherboard like this. So you got like your CPU, and then you just got your IO, whatever, over here. Just make that like rainbow coloured, just to show like input output and that. Just because of the multi things, you might have USB, audio, cables and whatever. So over here you would have your what they call Pci slots or PCIe slots. This is basically just where you put your cards in. So you might have an internet card. I don't think many people have that. It's probably mainly used for like servers and stuff. You might have a sound card. Again, those are not very used today because sound cards don't really do much anymore. Well, they might do much. I don't really know much about sound cards, but it's just that the CPU can produce good sound, so it's not much point of actually getting a sound card. So you have this simple CPU setup and that. So then if you want to install a graphics card, which might be like a GTX 1080 or so, let's do this. So this is your graphics card. This is what processes all the graphics. It's called, the chip inside of it is called a GPU, which stands for graphics processing unit. It's like the CPU but different. Obviously you'd have a fan on this, so if we just make a quick fan. This is just a model of a computer. Like if you look inside your computer, you might see all this stuff. Well, you should see all this stuff unless you're using a Mac or something, or a laptop. Laptops can be the same, but most laptops are like manufactured in a way that you can't actually modify it. So yeah, we're just gonna put this engine under here. Connect that up. Like that. So you'd have your fan on your CPU. Clearly you'd obviously have your fan on here, but that might be like a built-in fan or whatever to your GPU. CPU obviously needs a fan so it cools down, because your CPU gets really hot doing all the calculations. And then you might want some actual memory. So you've got your RAM, which is just like temporary memory so that CPU can run faster. It's just not really stored much, so it's only about 8 or 4 gigs of RAM. With your storage, you might have 128 gigs or something, standard or something, 300 gigs, 400 gigs. If you're really into building PCs, you might get a terabyte or multiple terabytes of RAM. If you're in a server, you might get like 60 terabytes or loads of it. If you're like production of like 5K video or something, you might get lots of RAM and stuff. You might actually have your own like built-in like storage unit. So this might be just your like simple hard drive here, maybe like 10 terabytes or whatever. This is your CPU, this is your IO, this is your graphics card, this is your RAM. This is just a simple link between these things. So I'm going to show you what's inside of this CPU at the start, and basically how it works. But first we've got to show you how it actually all links together. So first off, usually a CPU would look for an input. So if it senses an input from like a keyboard or something, if you press A, that key will go to the CPU. So there's two things in the CPU here. There's one which is called the CU, and there's one that's called the ALU. The CU stands for control unit, and the ALU stands for arithmetic logic unit. The CU is the thing that controls all the inputs, so it knows what pieces of binary is instructions and what pieces is just data and what to do with it and where to send it, and does all the stuff. And then if it thinks it needs to do some like math to like so if it retrieves like 1 + 1 or something, then it would send it to the arithmetic logic unit, and then what that will do, that will do the calculation, and it will send it back to the CU, and then this will output it. So this will output it to either like, it could go anyway, so it could go back to RAM to store or something. It could go to graphics card to process. It could go to actual memory to store up if you just want to store a number or something. It also could go outside. Okay, so it also could go outside the output signal, so that could go back to your monitor. If you have like a HDMI cable or something that you like standard or VGA or whatever, there's loads of different cables you can use to connect like a monitor to. So your monitor is just your display screen. So if you output a signal, maybe like to light up a little LED on the screen or something, or process an image on it, the CPU will just send it out to that. The RAM is just for quick access, because RAM is really fast but low memory, so sometimes the CPU will send a signal to RAM to collect some data from the actual memory, because this memory is quite slow because it holds lots of data. This can be mechanical, most of them are mechanical, but you can also get solid state drives. Solid state drives are basically just like floating transistors, which like they never actually move. Mechanical ones have a spinning disk in, which can degrade over time and can break and is like very slow sometimes. SSDs or solid state drives are really fast and usually the higher price and sometimes lower capacity, but you can get like 2 terabyte SSDs. So RAM is just really fast. It's about like, I don't know, loads of times faster than the mechanical one or your SSD. So basically the CPU just sends data to the RAM beforehand, yeah, so it knows what it's got to do, yeah, so it's got to send information from the actual memory to the RAM, so it can access that memory really quickly, because the RAM's right next to the CPU on the board, and this memory can be like far away, it doesn't really matter, but all you need to know is this really fast link between each other. Okay, so Today we're just going to be looking at what's inside of the CPU, so not really much about anything else, just like, wait, I mean change colour there. So yeah, we're going to be talking about not the CU, because we'll get that on a later episode, that's quite complicated, it's not really simple. We'll be talking about the ALU, so the Arithmetic Logic Unit. It's the one that does all the math and stuff. So we're going to be looking at actually building a simple arithmetic logic unit. It doesn't take that long. I'll show you other things that the CPU needs to use and stuff, and something called flags, yeah, on the CPU. So you'll learn a lot about how logic works and that, and we'll be using some of the logic gates and binary adders, and hopefully teaching you how binary works. So to start off, just gonna get a concrete out here. Let's build this out here. To start, we just want to get all the simple logic gates out. Obviously I did another video that showed all these logic gates, but these are the basic ones. You can build any different adder or logic or binary, different things, all different circuits with these ones. You don't necessarily need to use these ones, but the inverted is good, because if you want to invert a signal or do some like compacting with your circuit, it's a very good tool to use. Because you can invert just using the basic ones, but it does take multiple logic gates. So these are just simple logic gates that you need to get used to in order to understand the basic principles of what I'm going to be doing today. So just going to hook this up to this. So this one's called the AND gate, which says when you open up the GUI, and as you might tell, like, it's AND gate when both of them are on. So when this one and this one are on, it turns on, but when any other different combination, it's not off. So they've got both blue on to make this one go on. So if we disconnect these ones, so the OR gate, any one of these can be on, so this one or this one can be on, and then it will turn on. So it doesn't matter if this one's off and this one's on, it'll still turn on. It doesn't matter if this one's off and this one's on, it'll still turn on. And if both of them are on, it'll still turn on. So it only turns off when both of them are off. The Xor gate doesn't really have like a very clear name. It's Xor. You might be wondering what's the X for, because you get an OR gate, which is kind of easy to understand, but then you get an X, which is kind of complicated. So X stands for exclusive OR gate, so that's what it means. So this gate, actually, when you turn both of them on, it turns off. When you turn both of them off, it turns off as well. It can only be on when one of these inputs is off. So when an odd number of inputs is on, it will turn on. But if both of them are on, then it'll turn off. If both of them are off, then it'll turn off, whatever. So this can be used in loads of different things. This is going to be used quite a lot during our binary adding sequences, because it's actually a really useful gate. Sometimes it's more useful than the other ones. But yeah, this one's the one that does loads of the magic. So yeah, so if we break this down, so a CU, obviously, an ALU obviously stands for Arithmetic Logic Unit, which stands for just math and stuff. So obviously, if you want to have a computer, you obviously want to do addition. Like, if your computer can't add, then your computer's kind of not a computer. We're also going to be covering some subtraction as well in this video, so I'll show you how you can actually modify the add circuit to turn into a subtraction circuit, so you can actually switch between the two, like with the switch of a button. So I'm just going to get you set up with some binary knowledge. So if you don't know what binary is, it's just a simple code that computers use to communicate and stuff. It's the only code that computers know how to use. unless you're a quantum computer or some other different type of computer that doesn't use binary, I don't know. But all computers that standard day we have run on binary. This is like the simplest language you can get in the world. It's the lowest level you can get. It just consists of zeros or ones, or black or white, or whatever. Two different states, of which can be powered on or off. So binary goes up into powers of 2. So this is 2, 4, 8, 16, 32, 64, and 128. So it multiplies by 2 every single row. So this is 1, that's 2, that's 4, that's 8, that's 16, that's 32, that's 64. So if we go one more, then that's 8. So that's 128, but it's 8 bits long. And now a bit is just one column like this. So every time you add another bit, it multiplies by the previous bit. So if I add another bit for this, it'd be 256. So yeah, so 8 bits is actually called a byte. So you may have like 10 kilobytes or 10 megabytes or 10 gigabytes or 10 terabytes or 10 petabytes, whatever. You may just use that as your standard like storage media like unit. You may just like accept that's the unit, but if you don't really fully understand it, then you might get confused between them. So 8 bits is actually 1 byte. So to store like a character, you might just do this. Like that might just be a character. I don't know what that character is in real life. I might actually look that up. That could be like a letter. This could be a letter. That could be a letter. This could be a letter, and that could be a letter. Obviously you can't understand this, it's just a jumble of like paints and stuff, whatever, to your own eyes, but if you're a computer, then it will scan each one of these lines for each byte, and then it will take all that information and decode it and stuff, and actually might manipulate it and give you an output that actually we can understand as humans. So binary is really simple. So just add in binary, we get our 8 bits here. So it goes 1, 2, 4, 8, 16, etc. So if we want to start with 1, that's 1. So that's just 1. That's in hexadecimal. So if you want to do 2, it's not 2 like this. It doesn't go up 1, 2, 3, 4, 5. It goes 1, 2, 4. So that's a 2, so we put that on 2. Now you may think, oh, okay, 3 is this, but 3 isn't that. 3 is actually 2 and 1, so it's just a simple addition, so it goes 1, 2. So if you want to do 3, you actually have to add up 1 and 2, so any odd numbers, you actually have to add a 1 here. So that's the only odd number in binary, so you have to do that. So obviously 4 is going to be 4 here because it goes 1, 2, 4 as it goes up in the power of 2s. And then 5 is just gonna, because it's an odd number, you gotta add 1 odds at the end. And then 6 is 4 plus 2. And then 7 is 1 plus 2 plus 4. So that's just the line of 3. So that's basically how you count in binary. Now you may think, oh, that's kind of simple, but how do you actually add in binary? Now obviously if you get two numbers like this, you could probably work out what they add up by just doing it in your head. So like, you could work out that that's 5 and this is 6, and you may be like, oh, that's easy, let me just put the answer, it's 11. So like, that may take you a while if you're not really experienced in binary, but if you want to do it instantly, you can make a circuit that does it for you. And this is basically what computers do every single day, but a thousand times a second. Well, billions of times a second. So basically, you just want to start with a 1-bit adder, because if we build a massive adder, like that proper calculator or something, it takes too long to build, and it's just ridiculous. So you want to start with a simple Xor gate and then the AND gate. So you want to have your two inputs here. So this is going to be your 1 bit and your secondary 1 bit. So you're going to have two numbers here, maybe like this and this. So if you want to do like 2 plus 1, then it will output 3, so that's 3 there. So that's basically what this thing will do. But this is only for 1 bit, so it will do this. I don't know why it keeps on doing it. So it will be like, if you want to do 1 plus 0, it will output 1. If you do 0 plus 1, it will output 1. If you do 1 plus 1, it will actually output 0, but then carry on another bit over here. So clearly this is not the circuit here, obviously, because it's too short. But 1 bit added actually carries on a number if you go over its limit. So if you add two numbers together the same, then it will go over its limit, and like, it's called a shift number. So you shift it over to the next one, which will add on to the next digits. So it's kind of like simple numeracy. So you just want to connect both of the connections to this Xor gate, and both of these connections to the AND gate. So when both of these are on, it'll go into AND gate, obviously, because that's what we taught you. So when both of these are on, we said that it wants to carry something over. So we'll have an OR gate here. There. We'll have a simple output here. So when both of these are on, that output's over here. So we'll have a binary display here. So this is just like a 2-bit binary display. This one's the output of the first digit, this one's the second digit output. So as you can see, 1 plus 1 but in binary is 2, which it stands here because it goes 1, 2 in binary. 0 plus 1 is actually 1, 0 plus 1 is 1, and 0 plus 0 is 0. And you may think, oh, that's all good and stuff. But then you're like, oh, what if you want to shift it over? So this is actually called a half adder. It's not actually a proper adder yet. So if you want to, because you actually need to include the shift. Now on the first digit you don't actually need to have a full adder, because there's nothing shifting into this adder unless you've got some memory bit that might be storing something. But on the first bit you don't actually need any inputs coming into the side of it, so you only need a half adder. But on the bits to come, because you're going to be shifting over bits over and over, you're going to need another bit that adds those to the current number, so that carries it on. So to build that, you just want to basically just add another half adder on it. If I can get this right. There you go. So you just add another one of these on, so an Xor gate and then the AND gate like this 2 button here. Now you just want to connect this AND gate up to this OR gate as well, so it's both connected. Then you want to connect this to there, and this to there. So basically what we did with that, and you're like, oh, where's the second input, because we've only got one here. Now the second input's just going to come through here. This is an OR gate. This is the shift one, so this is going to be the carry in, which is what we call it. So like if we shift over a binary digit to like the second digit, it will go through here, and then we'll add it to the current number over here. And if there's one here, then it will shift it over again and shift it over again until it's all added up perfectly. So yeah, that's basically your full adder. Now we can stack these up quite a lot. In fact, we could make a 2-digit binary adder. So we don't actually need, we only need a half adder for this one at a minute. This. But then on this one, we actually need a full adder. instead of a half adder. So I'm just going to go over one like this. So this is going to be a full adder. As you can see, we've doubled up the half adder, and we've got an OR gate here. We don't really need this OR gate because it's only a 2-bit, so we're not carrying anything outwards unless we want to do like overshift or something. I'm going to take these ones away, and we're actually going to have 2 bits here instead of the 1 bits that we used to have. So first bit goes here and here, and that first bit goes there and there. This first bit goes there and there. This first bit goes there and there. So then this connects to that, and the AND gate connects to that, like standard, usual. This will connect to that because that's the overshift. So once this goes over its limit, which where it shifts over, it will go into this one. So it'll add it to the number of this. So then that will go to that, and that will go to that half adder, and then this will be the secondary input as well. So that will go to that. Then we'll actually get another 3rd bit involved as well, because if we overshift, it needs to go to a bit. So if we do 3 plus 1, that's 4. As you can see, 1 plus 2, 1, 2, 3. No, 1, 2, 4. That's what I meant. That's how you count in binary. So as you can see, we've just added a number. If you want to do 1 plus 1, it's 2. 1, 2. 1 plus 0, it's 1. If we want to do 3 plus 3, it's 6, because that's 1, 2 plus 4. So it's 4 plus 2 equals 6. So that's basically how you like decode binary into hexadecimal and how you actually add it up. Now you may think, oh, you were talking about subtraction at the start. So yeah, we're going to be talking about subtraction now. So subtraction is actually quite it's quite unique, because you don't actually have to make a separate circuit, you only have to add to the adder. So we actually need a separate switch here, which will switch between circuit and stuff. So these second bits here, we don't want those to be connected to this. So the bottom ones don't even want to be connected to anything. Your second bit doesn't want to be connected to anything. You want to add another logic gate here. This wants to be XOR here. Here we go. Then you want to connect all these, and then you want to just do a simple thing. Connect this one to there. Just do the thing like that. So it'll still add up like usual, because an XOR gate turns on when there's only one input, and there's only one input because this is not turned on. So once you turn this on, it actually turns it off. So it's inverted, that column right there, when we do subtraction. So basically it inverts the adder, so when you add, it actually doesn't add. So it's kind of weird how it works, but you have to understand how everything goes together. You might want to watch a different video about how adders go in more depth, but it just makes it so it doesn't actually add 1, it adds 0, and it does something to the binary. Obviously if we're taking away, maybe if we do 3 take away 1, and you maybe think, oh, that's 2, but then you're like, oh wait, that says 5 there. But technically it doesn't say 5, it says 2, but the 2 is actually inverted and the out ones are turned on, so the whole output's inverted when you do this subtract one. So a quick fix around that is just to invert, get XOR for each one. Then all these outputs here can be inverted by the switch of a button. Just like that. So as you can see, you just want to connect this up to this, this up to this. So basically it inverts it during the process of adding, but then it de-inverts it when it like comes out. And when you just go into add mode, it just does everything correctly. So 3 plus 1 is 4, obviously. When you go into subtract mode, 3 take away 1 is actually 2. And we can do 2 take away 1, which apparently is that. I don't know why that's happened, maybe. I don't know, maybe that was just a glitch or something, maybe the Xor glitch. But you can understand the simple concept of adding up binary and that. And that's how you do subtraction and adding in Scrap Mechanic and any other game that includes logic. Cause I know that like Stationers and other games have very good logic and actually do use proper terms and stuff for the logic gates, and actually really fast, because 1 tick in Scrap Mechanic is 0.025, so you can actually make some quite fast circuits, and in some other games logic is really slow and it's got like an animation to it, and it's very quite useless. But in Scrap Mechanic you can do like mental creations and it's really good. So I hope you enjoyed this video on logic gates and how a computer works. This is going to be the first part of many series about how different parts of a computer works, and it's just going to be displayed in a format on Scrap Mechanic, while we'll build our base up here as well. I might do some base building like live streams or videos as well, so yeah, stay tuned, put the post notifications on and whatever. Yeah, so bye.